This webinar is organized under CEFIC, so competition law applies. Please avoid sharing CBI information and keep all questions and comments within today's scope. You can see the checklist displayed on your screen. Please keep your microphones and cameras off. No transcriptions or AI tools are permitted for CEFIC meetings and events. This event is being recorded and the recording will be published on our website at pinfa.eu. Please check your own connection and browser settings. We're unfortunately not able to provide IT support during the session. Post all your questions in the chat at any time. Thank you all. I now hand over to Dr. Thomas Futaha, Chair of Pinfa, to introduce Pinfa and to welcome our speaker, Dr. Michael Grosshauser. Thomas, over to you.
Thank you very much, Esther, for your kind introduction. Yeah, also welcome from my side to this first Pinfa Sparks webinar. And before we start, let me give you a short introduction to Pinfa. Next slide, please. Yeah, so who are we? We are the Phosphorus Inorganic and Nitrogen Flame Retardants Association, and we have been established in 2009 as a sector group within CEFIC. And this association represents 26 members, including manufacturers and users of flame retardants, of non-halogenated flame retardants. We also have Pinfa North America and Pinfa China as sister associations. And we have a global network of institutions, of companies who support Pinfa and the members. Next slide, please. So we as Pinfa, we are representing the phosphorus inorganic and nitrogen-based technologies, which can enhance or which do enhance fire safety in materials and plastics. And that's the topic today, plastics, but also textiles, foams, and electronics. And these flame retardants, they contribute to reducing flammability and lead to a slowing ignition process. Next slide, please. Yeah, here you see the contribution of flame retardants on the right part of this scheme. Because with flame retardants, you gain more time for firemen, time for escape, time until the fire develops fully. And so with this functionality in materials, you are able to save lives and goods. Next slide, please. Yeah, and here you see the Pinfa members. So these are the member companies in Europe, China, and North America. And then we go forward to the next slide, please. Yeah, and here we see our Pinfa Europe team with our executive team, with the colleagues from CEFIC. And the picture in the middle was one of our last general assemblies in Amsterdam. So we see happy and happy faces. So next slide, please. So what are our members' shared visions? So the vision is to continuously improve the environmental and health profile of our flame retardant products, offering innovative solutions for sustainable fire safety. And we are committed to maintain high fire safety standards across the world and minimize the risk of fire to the general public. Next slide, please. Yeah, so also please stay connected with us on our website and also follow us on LinkedIn. And the next one, please. Yeah, and now we come to the topic, recycling. And I also welcome Michael Grosshauser for his contribution to the recycling of halogen-free flame retardant plastics, challenge or solution for high-value applications. And here you see how it all starts with the recycling on this picture. So you don't recognize most of the parts, but some parts are still recognizable. So how can you order this big amount of materials and how can you go forward from there? Michael, it's now your stage. You're the expert on recycling. You're the expert on plastics recycling and the plastic materials. So the stage is yours.
Thank you, Thomas, and thank you for the possibility to speak to all of you here. Yes, today I want to give you an overview about the recycling of halogen-free flame-retardant plastic, and especially on the last 10 years of cooperation between Pinfa and Fraunhofer LBF. Next slide, please. And here's the short agenda from, I will say a bit about Fraunhofer LBF, the motivation, the basic material quality, how we determine that, and a short overview, really short overview of the projects in cooperation together with Pinfa, and in the end, a summary and take-home message for you. And also here on the right side, it's from the same, let's say, recycling plant we visited together with Pinfa, and there are some pictures all over the presentations from this visit, which was really something that stays in mind. And the next slide, please. The next slide, Fraunhofer LBF. You see the nice picture of the building, but yes, there's the Fraunhofer organization as a whole. So, you know, all the institutes and all the employees and the whole financial volume and the funding and everything. So if you don't know Fraunhofer, just reach out to me or my colleagues. We will tell you more about it. Next slide, please. And also next slide. All over the world, there are several bureaus. So if you are from somewhere all over the world and see there's a bureau next to your place, reach out to there or reach out to us in Germany, and we can direct you to the ones somewhere overseas. And next slide. And from my side, as part of Fraunhofer LBF, so the institute in Darmstadt, and so we are focusing in the terms of plastic from synthesis and formulation in the beginning, over the additivation and material analysis and characterization to the final plastic processing and component design. So this is along the value chain of plastics. So if you have some ideas or some needs or something, reach out to me or my colleagues at Fraunhofer LBF, and we could help you or direct you also inside of Fraunhofer Society somewhere. Next slide, please. Also, these pictures are from the visit at the recycling plant, and I will go a bit more into depth about the motivation. Why are we doing those projects together and together with Pinfa also? Next slide, please. Just to give you an overview, our European framework, it's quite complicated, and I don't know it in details, and I don't know if someone knows it in details because it's so complicated. But I wanted to do this slide a long time ago because it gives you an overview. Let's say 1973, it's over 50 years ago, so half a century. And you see in the beginning, it was lots of decades, which was just what's waste and how can we look in that the waste is not dumped anywhere, and there's a regulation about waste. It's going up to 2000 to first things about what do we do with end-of-life vehicles. And after that, after the beginning of the 2000, it started up to the 2010s, a clear transition to going to a circular economy. How can we improve circularity? How can we make the materials we use more sustainable? And so let's say from 2019, it's really a targeted focus. So on plastics and on recycling rates, and how can we go from that point to, let's say, give products a more sustainable, you know, not just sustainable itself, but also more on a side of where are the sources, to keep the sources inside of a circular economy in Europe. And the next slide, please. And just to give you the growth of the recycling industry. So we see in the last 10 years, there was an increasing number of capacity of recycling. There is a huge amount of companies, so 815 from 2024. The numbers are from Plastic Recyclers Europe. You can all see them on their page. It will be probably updated in some weeks or months. But you also see in the last years, you had a bit of stagnation. And this is, you know, some topics I will go later on, but there are some topics in the market and things we also have to consider at some point. But you also see a lot of materials are getting recycled, and there's a lot of things coming back, and the possibility is there, and also a big turnover in billions of euros, and about 30,000 employees, which is also quite big. Next slide, please. And this is what I meant before. There are several topics. When you look into the media somewhere, there are topics from Europe is losing recycling capacity, and despite rising regular demand, and over the problem is not a lack of potential, but lack of viable market conditions, because recycling plastics takes some effort, and this effort must be considered in the price afterwards. Could be some problem, also is a problem compared to very low international virgin market prices. And we have a lot of high value plastic streams that remain unexploited at the moment, which has some big potential. And policy is at the moment doing itself quite complicated, and the market reality is struggling against it. So they are misaligned at some point. But what we need to have in focus, that Europe has the feedstock, the technology, and the knowledge to scale up plastic recycling. But without the stabilizing markets and the unlocking of the high value, this potential will be unused at some point. Next slide, please. Just to give you an overview, in the past, we used the left part. So we went from virgin plastics to flame retardant products is state of the art. So we produce plastics, we keep them equipped in compounding steps, and we get the flame retardant compounds or products from that. So what are possibilities to get more sustainable? So we could use post-industrial PIR recyclates or PCR recyclates, but the sources are sometimes very diverse. So as I said before, there are some sources that exist, but they are not used at the moment. On the other way, it could be bio-based feedstock, which I will not go into depth on this presentation, but there's also some possibility. We could use for some things PLA or drop-in solutions, which could be used. And finally, which is regarding the quotas that are coming up, closed loop solutions is a big point. So, and especially if you look at sorting plants, they say they cannot go into, for every kilo, they cannot go for every material. But if we could have closed loop solutions for specific applications, this could be some solutions to get materials back. Next slide, please. The way we go today is we put a lot of effort, money, energy in a base material. We went up the material value and a rising amount to the product. And in the end, after we use it, it went to the incineration. And a lot of flame retardant plastics, especially, are going to incineration afterwards because they cannot be sorted in detail. So that's what I meant before, because we could use closed loop materials. So just give you a number. 5 million tons of technical plastics and the waste streams in the EU every year, some number are found. And a large share of this is incinerated because you don't find numbers how much is used for that, but probably the most part. So there's a lot of material value that gets destroyed. And next slide, please. What we want, or what would be more getting us to the goal, we enable the longer lifespan from flame retardant materials by reusing them. So we increase the price by material recovery up to a product again. So we keep the high material value in the loop. And this could be the representative of a major circular opportunity here. And we need targeted recycling and material upgrading and R&D and to be transformed into high value products in the end. And in this case, innovation unlocks the value, and it's not just waste incineration afterwards. Next slide, please. Just to give you a bit overview on basic on material quality. Next slide, please. I want to make a short overview because some people don't get the difference at some point, between virgin, post-industrial, post-consumer recyclates. You see here from left to right, and the virgin plastics that were produced from the raw oil, from distillery and everything, steam crackers, sorry, and they go through manufacturing, and there is some loss in manufacturing, and some, let's say, products that don't get in the market, they can go back as post-industrial recycling. There's also a large amount of material that is not used at the moment. This could be a potential for bringing more material back in use. But also afterwards, we have a consumption phase because everyone, you and me, and we are using plastic packagings. We are using technical products, our cars, houses, everything. There's plastic in there, and especially high value materials. And after the lifetime of the used product, we get post-consumer plastic. So then it's, let's say, a secondary raw material. But we need a recycling step afterward to get it in a used post-consumer recyclate. And this step is sometimes a bit problem, as I said before. And the big difference between the left part and the right part is the homogeneity. It gets more diverse to a really heterogenic material from left to right. But also we know exactly what happens to a virgin material when we process it, but we do not know as a first glance what is going on in a post-consumer recyclate, because you don't know what impurities can come inside. And we have no external influences from virgin materials and many influences from by the post-consumer from external influences. And characterization can be carried out with no problems. There are standardizations in virgin materials, which is no problem. On the right side, there's a large variety what can be done on recyclates, and there's not so much like things we need to do or standardization behind that. Next slide, please. And also just to give an overview, what are the challenges they go up? So there are fluctuations of the materials, the degradation of the polymers, and the odor, of course, everything that degrades or is changed between the lifetime oxidizing of plastics or something else, or additive fractions that still are inside some materials, they are going into odor, for example. They can be some things that leave afterwards, the materials. Compositions get newly, in a recycling process, you get really different materials coming together to get new compositions and all these impurities. And this is something you have to tackle at some point. Next slide, please. And there are some things you can do just for thermoplastic polymers. On the left side, restabilization is key. If you have, for example, you can enlarge the lifetime and elongate the lifetime and the recycling stability with new restabilization. And this is all things we've done at our institute with several materials. And compatibilization, of course, is a big topic because you have a lot of blends in PCR materials, and also blends between, let's say, aged materials sometimes and new materials. So you have to work a bit to bring those materials together. And this is composition dependent, of course. And in the end, of course, if you have polycondensates, you can always do the chain extension. And you can repair the materials to some degree. And this is quite a smart move to do that at some point. Okay, thank you. And next slide, please. I want to now go into the detail on the projects in the cooperation with Pinfa and the Pinfa member companies. Next slide, please. It all began over 10 years ago with the recycling of halogen-free flame retardant plastic. So it's a big topic, but what did we do there? Next slide, please. It was a model-based project with a scope of systematic investigation of 10 HFFR model systems. You see them on the bottom here, or the left bottom side. And also it was quite well accepted from media. So we did some publications there because some interest all over the industry. Because there's the basic investigation was, if we have flame retardant plastics and we do a simulation in this field, what's happening when they get recycled? What's happening if they age and you want to reuse the material afterwards? And we started to do that in a simulation way. So we know what we put in there from an energy side and from a processing side. And next slide, please. And here you see the first systematic procedure. So we did a multiple extrusions to look inside the material, what's happening if it will be reprocessed. So we took out material from the first extrusion step, the third extrusion step, and the fifth extrusion step. Then we got granules out of that. We made characterizations and testings out of the granules, of course, but also we did injection molding and tested those injected molding parts. Next slide, please. The next thing we did, yes, thank you. And we put from the first extrusion, we used our compounds, we did an aging, and then we did an injection molding afterwards. So we had, let's say, a simulated use phase in the injection molding materials. And also we did injection molding and we did an aging of the test bars, and also tested, you know, performances of the materials before aging, before injection molding, and so on. So this was for the simulation of the aging due to the using time. Next slide, please. So we had several results here. So from multiple extrusion, after the 5 extrusion step, flame retardancy maintained from 9 out of 10 formulations. And the 10th one was not going that bad. So it's just a small degree after most optimal possible way. And glass fiber shortening, you see it on the right side here, is happening over this time. So the problem was more like not the flame retardancy. The problem was more that the material and the glass fibers, they decompose over the time. And also the accelerated aging, the flame retardancy was maintained. And what we have in general, what you can expect is the darkening. You see it also on the right side here of the material. And we used several flame retardance testings. You see that on the bottom. And the essential data sets, they show that the recyclability of HFFR plastics are possible. Next slide, please. And after that, there came COVID-19. So there was always also a bit of, you know, going around asking, oh, what's the industry doing? And we focused together with the companies of Pinfa and partnering companies. What can we do, you know? And we came together in an industrial joint project to look for real recyclates that are in the market. And you probably, you know, in the beginning of the 2020s, it was kind of hard to get to real PCR materials and PIR materials. At some point, there were a lot of materials were sold out. And that we looked at the tailoring for HFR performance of recyclates. Next slide, please. And the 10 companies, they did a pre-competitive industrial joint project. So they paid for the study itself. So we had recyclate suppliers, compounders, flame retardant producers, and competitors collaborating here. The objectives were validation of PIR, post-industrial and post-consumer recyclates, for upgrading into flame retardant plastics compounds, the assessment that is needed for adaptation of the flame retardant standard formulations if needed, and identification of upcycling suitable material flows, and a very long-term performance and compliance of with the project. So we used multi-source recyclates and did a characterization with the methods you see, and we have application-driven formulations we did together with the participating companies for the materials you see down there, and also the thermal aging from 1,000 to 2,000 hours up to 150 degrees. And this collaborative R&D method enabled a high-performance flame retardant applications are basically doable based on the recyclate plastics. Next slide, please. Just to give you an overview, the material types we looked into inside of this project, the applications that could be done with those materials, and the sources we evaluated for this project. Next slide, please. And it's a wrong, it's not a project methodology, it's the results. So just to give you a glimpse, there are so many, it's like a big report we had there, but some of the results were that best classifications in UL 94 were reached for the materials before and after aging, for polyolefins, for the technical PA6 and 6.6 grades from recycling, and for PET, and also PCABS. And GVFI, GVIT were done, and they were really in a good values, 850 degrees and 800 degrees GVIT for PA66, and 960 GVFI for PA6 and 6.6. CDI at 600 volts was reached for PA6 and 6.6. We also did cone calorimetry, and it also showed really stable materials, reasonably stable values for the time to ignition, time to burn, peak heat release rate, total heat release rate, and the medium average release heat rate. And for almost all the recyclates we did, there were some materials that ran out of the scope. But also here, as similar to the first project, the problem was most of the times the polymeric quality. So yeah, and we tested phosphorus, inorganic, and nitrogenic flame retardants. So basically also the Pinfa materials here in different formulations together and synergistic formulations. And also you see pictures here from these materials we tested inside of the project. Next slide, please. And then there's another project, public funded, on the upcycling of halogen-free flame retardant materials. And this started last year. Next slide, please. And what we are doing there is we can specific waste streams that are at the moment not used for high value plastics be upgraded is the main questions we try to focus in this project. And also use untypical recyclates like mixtures of PE, PA or HDPE from multi-layer films and so on, you know, to get a possible new application out of them. And we're doing intense analysis, which is for a public funded project, it's possible to do that. And to give you the industry afterwards an overview. And just to give you a short overview, we got over 30 different recyclates from different sources and different materials. We procured them, we have them in our house right now. And we are currently compounding typical flame retardant formulations for each, up to 10 for each recyclate type, to give a broad overview and see how that characterizations in the beginning probably interact with the final results of the flame retardancy and see if there's some things that play into. Next slide, please. And in this way, I want to thank also the companies that helped us the last 10 years or supported us in several projects aside from fundings and everything. Thank you very much. Next slide, please. So I will come to the end. I think I'm in time. I don't need to hurry the end. So next slide. And I will summarize a bit. So what did we learn? What can we take with us? So recyclates have a large variety. So there's in characterization is necessary, therefore. The properties can reach really different performances. And what one can take with him or her is the halogen-free flame retardants. They perform in recyclates similar to virgin materials. But of course, the recyclate quality is something you cannot just buy any recyclate and say, I will use my formulation, because especially impurities need to be worked up and can work antagonistically. Not every recyclate type is suitable for upcycling. We found out that some of the recyclates are on a really nice analytic perspective, but they are not usable for long-term stability and not long-term stable applications. And you need to fit formulations at some point after you have characterization of your materials. So, and sometimes it's not possible that they fit because the variation is higher. So one need to think about, or everyone who wants to use recyclates, are the specifications I use suitable for recyclates? And to get deeper in the knowledge for the characterization and analyzation of the waste streams, we need to carry out broader studies. So we also need to know what happens when materials come back, when, as I said in the beginning, with closed loop systems, and also after especially long-term usage time. And a lot of topics regarding interactions between additives, flame retardants, fillers still unknown and will be handled in future projects, hopefully, with not just from our side, but from all over the other research institutions. And this is a very complex question, and we need more cooperation between every player along the product value chain. So the time for everyone to act is now, and reach out to us, all the partners in Pinfa, partnering companies and all other research institutions to work together. And in this way, next slide, please. I want to give you the opportunity to take part at the next industrial joint project, which will start this year, which will focus on just post-consumer recyclates, how they can be upgraded, and also how are they working in a closed recycling and a closed loop recycling, and therefore HFFR up to cycle. Of course, feel free to reach out to me, Pinfa companies, and next slide, please. Also, if you are interested in recyclings, look at the plastic forum plastic recyclates in Darmstadt will take place in March. And it's not so far away from Fraunhofer LBF, so you will have also possibility to look into our institute here. And I'm very happy if we could welcome you here, and it's an industry-based exchange there. Next slide, please. And I think I'm in time, surprisingly very good in time. Thank you very much, all of you, to hear what I said just and what I present. And thank you, Pinfa, for giving me the opportunity to talk to every one of you. And I'm looking forward to the question and answer afterwards. Thank you.
Thank you very much, Michael, for this insightful and comprehensive presentation.